Alright guys, so today we are working on our test review and we are using our Desmos calculator. So the first thing that we're trying to do is figure out our mean, median, mode, and range. So for that, on Desmos, what you're going to do is this plus sign, and then we're going to create a table of values. And it doesn't matter which letter you use, honestly. But if you type underneath the x values, then this is your x1 data. So that's what we're going to do. We're going to type these in. 8, 6, 5.5, 4.25, 4.5, 6, 7.5, 7.75, 7.75, 8, 6, 7.5, 6.5, 6, 6.25, 8.75, 7, and 6.75. So now I have all my data in here, and I need to figure out my mean, median, mode, and range. So the mode, you don't need to use on Desmos. It's whatever occurs the most. So this is most. And what number occurs the most that I'm seeing is 6. The range is the biggest number minus the smallest number. So our biggest number is 8.75. minus our smallest number, which is 4.25, and 8.75 minus 4.25, my goodness, sorry, is 4.5, sorry. And then the median we're going to get on Desmos, so we make sure that we have this keyboard showing, and then it's functions, oops, I'm sorry, I forgot to click the next box. Click the next box. Functions, we want to go to stats, and we are going to click on mean. And then the title of our data was x1, so that's what we type. And we have a mean of 6.17. And then we're going to do the same thing with their median. We click on the next box, functions, stats, and then our median. So they should say pretty much what it is 6.5. Like the names on Desmos reflect the names that are on your paper. So that's how you do 1 and 2. Dot plot is pretty simple, so we're going to look at number 5, and then you're going to graph it on number 7. So all you have to do is put the dots above the line. So I have 1 for 13, so 13 gets 1 dot. Then I have a dot at 17, so I'm just going to read my data going across, and you just put dots. If you see more than one number, then that number gets an additional dot. 21. 13, 22, 17. Oh, there, you should try to make them nice and even. That's my bad. 20, 17, 15, 23, and 15. So there is our dot plot. Okay, next we are going to do a box and whisker plot. Okay, so here is our data. We're going to type all that into Desmos, so I'm going to get rid of this, and then I'm going to get rid of this. Whoops, heavens. Okay, plus sign, table. So if I wanted to, I could type x2 up here, if I wanted to. Okay, and I'm just going to type in my numbers. 4, 11, 1, 13, 4, 4, 6, 20, 29, 12, 1, 2, 7, 5, 8, 11, 4. Okay, and then we click the box underneath it, and we're going to create our box and whisker plot. So for this one, we're going to go to stats and stats. And then our name of the table, or the name of the data, was x2. So that's what we typed next to this, x2. So like if I typed x1, nothing's going to happen because that's not the name of my data. And the name of your data is whatever's on top of the box, or your table. Okay, so this is what we need. The min, Q1, median, Q3, and our max. So for box and whiskers, the min and the max get dots. So our min is at 1, so we put a dot here. And our max is at 29, so like here. The quartiles, Q1, the median, and Q3 all have lines. So I have a line at 4, a line at 6, and a line at 11.5. We connect the lines to make our box, and then to make our whiskers, we go from the middle of our box straight out to our dots, and that's our box and whisker plot. So basically what's happening is we're splitting up our data into 4 or 25% each. So 25% of our data is here, 25% of our data is here, 25% of our data is here, and 25% of our data is there. So the more tight or squished a line is, the more data you have in that area. So for this line, or for this piece of data, most of the data is towards the bottom, and then this guy, there's not very many data scattered here because it's so much longer, so it has the same amount of items in each of the 4 quartiles, but because this spans so many numbers, it means that my numbers are really far apart, okay? So the closer they are is where the majority of your data is. So that is a box and whisker. And then you can do one on the World Series underneath. A histogram. So a histogram, we don't need to use Desmos. Basically, a histogram is kind of like a bar graph, but you have ranges. So the ranges are at the bottom, and then each box going up is worth 1. And we're going to count to see how many are in each of these ranges. So from 1 to 5, I don't have any, so I'm not going to put that on my picture. 6 to 10, I don't see any in there either. 11 to 15, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we count how many we had to represent that range of data, and then we draw our bar. And this creates our histogram. Okay, 16 to 20, I have, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 21 and 25, we have 1, 2, 3. I think I got all of the data. I always like to double check. Okay, this is my histogram. So lovely. Yep, got it all. Okay, now we're gonna keep going. Okay, so the next one, number 15, is the histogram as well, but we just did this histogram on the other side, so we're not going to do it now. Okay, 17, we are going to do the mean and the standard deviation. So when you think of standard deviation, I want you to think of population because of Desmos. Okay, so let's do this. So we're going to type these guys into our computer. So let's get rid of this and this. Oh, heavens. I always do that. Okay, table, and we're going to type all the values into X1. So we've got 70, 62, 60.4, 44.8, 30.6, 68, 68, 34.6, 37.8, 45.4, 69.4, 29.6, 53.2, 69.4, 1.6, I wrote that right. 11.8, 69, 53, 49.4, 24, 54.8. Okay, so the first thing we need to do is we need to figure out our mean. So our mean, we go to functions and then mean, and I think that this is behind what you can see, so I'm really sorry. Hopefully you can see a little bit of it. So the mean is our X1 values. So we get 48 point, oops, that's not a good 8. 48 point, I guess we could round, so 90. It's close enough. And then standard deviation, you are going to use the button that underneath the stats, and it says STDEVP for population, which includes all of our numbers. If you just do the other one, it cuts off some numbers, some like outliers. So our standard deviation is 17.73. And the standard deviation basically means how far away our numbers are from the mean. And the bigger this number is, the further apart our numbers are. So we want this number to be small so that we have good data. Okay, now we need to talk about these guys, distribution of pictures and the data. So it kind of helps if you kind of trace them a little bit. Oops. Okay. Ooh. And then this guy. So we have 4 main types of distribution. We have this one, which is symmetrical. Symmetrical. Then we have this guy. Oops, I did a terrible job tracing him. And we have this guy. Now if you notice, they have really long tails, which means that their data leads to one side. Okay, so we call this skewed. And it's skewed whatever direction the tail is. So this tail is on the left, so this is skewed left. And this tail is on the right, so it's skewed right. If you make like a boxy shape like this, then your data is called uniform. Okay, last but not least, we have to do our line of best fit and correlation coefficient. Okay, so let's look at this. We're gonna get rid of our Desmos information. Okay, again, oh man, every time. Again, we're gonna get a new table, so table, and we're going to put this value on our table. Now, this top line information, the top line is our x values, and the bottom line are our y values. So we're gonna type those in, and it really helps me if I label them first. So I encourage you to label them as well. And then our y values, we've got 0, 70, 114, 177, 232, and 255. Okay, so now we're trying to figure out the line of best fit. So the line of best fit is basically our slope-intercept formula, and our slope-intercept formula says y equals mx plus b. It's slightly different, but that's basically what we're going to type into Desmos. Now here's the difference. We have a table above, and my y's are y1 and my y1 over here, and my x's are x1. So I need to include that information in my slope-intercept. And the only other thing that's kind of weird is you need this little guy in order to get the slope-intercept. So, oh heavens, we went away. Plus b. There we go. All right, so now this is the information that we need to create our line of best fit and our correlation coefficient. So m, remember, is our slope. So for the line of best fit, it's always y equals, and then whatever your m is. So we've got 20.80. Followed by the m, you always have your x, and then we add our b. So that's our y-intercept. It's at 23.46. Okay, now we have to talk about the correlation coefficient. So the correlation coefficient is basically saying, are your numbers really close to the line of best fit, or are they off quite a bit? So if we look over here, we can see our graph and our scatter plot and our line. So notice how our line of best fit goes really, really close to all of our data. That means that we have a really high correlation coefficient. So they're almost 100% touching our data. It's not quite there on some of them, and if you zoomed in and were able to find them, like I am not, if you notice right here by this 180, he is off a little bit. And over here again by the 260, he's off a little bit. So not a perfect 100, but pretty darn close. Our correlation coefficient is this R value, so it is 0.98. The closer the correlation coefficient is to 0 or 100%, the better your data is, because we want that linear pattern, which basically says that my data is increasing at the same rate each time, or decreasing. So this is an increasing problem because I have a positive slope, but sometimes you have negative slopes, which would give you decreasing problems. And that just changes your R value to a negative, which is fine. So the closer you are to -1 or +1, or -100 and +100, means that you have a strong correlation coefficient. So since this guy is really close to 1, he has a strong correlation coefficient. The closer you are to 0, the weaker your correlation coefficient. So like 0.4 would be pretty weak, especially like 0.2 is very weak. And no correlation would be like a 0, a score of 0 for your correlation coefficient. And that basically means that you have this cute little line and your dots are all over the place and they don't really make a pattern. Okay, so now we got to solve these problems. And I'm going to do 2 examples, one of each type. So if you spend 150 at Lagoon, how many hours have you spent at Lagoon? So I like to use my table to help me figure this out. $150 money that I spend at Lagoon is my Y. So this is my Y. And then how many hours we've spent there is my X value. So what I'm going to do is I'm going to use my line of best fit, and I'm going to take out either my X or my Y, depending on what the problem gives me. On C, I gave you that Y is 150. So I'm going to take out my Y and replace it with 150. I leave the rest the same. 20.80x plus 23.46. So now we have to solve for x in this lovely little two-stepper. So the first thing we need to do is we need to get our variable by itself. So we are going to get rid of negative 23.46. So we subtract 23.46 on each side. So 150 minus 23.46 is 126.54, and that is equal to what's left on the right, which is 20.80x. To get this variable by itself, we then have to divide each side by 20.8, and it's the same process each and every time. My x, or my hours that I spent at Lagoon, in order to have spent $150 at Lagoon, is 6 hours and some change. Okay, now this is just based on this information. So if this information is slightly different, then my numbers will also be different. Now let's look at E. If you've been at Lagoon for 8 hours, so hours spent is our X value, so I'm going to put a cute little X here. How much money have you spent? Money spent is our Y value. So I'm going to again use my line of best fit. At this time though, I know what my X is, so I'm going to take out my X and replace it with 8, but I'm going to keep my Y there. So Y equals 20.80. Since my X value and my slope sit right next to each other, it means that they're getting multiplied. So when I take out my X and plug it in, then I'm going to be multiplying by my slope, plus 23.46. So all you have to do for this one is plug it into the calculator, and you will get your correct answer, plus 23.46. So we get a total of $189.86. That's how much money we've spent at Lagoon if we have been there for 8 hours. And again, all I did was I just plugged this 8 into my calculator, and I got my number, and that's it. Okay, if you have any questions, please let your teacher know. Have a great day, guys. Bye!